methods of charging, right? So we need to understand what are the different methods of charging a material, right? See, one thing wherever possible, right, I'll try to show you with an activity. Okay. So is anyone ready to come and do? Hari Raghava. Suma vada, jolly. Come on. Did you see them? The other guys. Did you see the other guys? They are outside, the one who were inside. Okay, that's you. You take care. பையன் பண்ண போகும் அங்கேருந்து ரெக்கார்ட் பண்ணும் அங்கேருந்து எடு see இன்னும் தெரியுது can you explain to them what we are able to see just show it to them no yeah you can open and show it so it will fly down okay let's switch off the fan see what is this actually aluminum ulla potra idu enna basically what is this outside you have a plastic box plastic is a conductor or insulator so the advantage of this plastic is will you be able to create charge on that or not see understand one thing you are saying plastic is an insulator but by you saying it as an insulator is it possible to create charge on that or not you can create charge but what is it you cannot achieve you cannot make the charges move within itself right so that is one thing so you are able to plastic box then what are you able to see inside aluminum foil you have an aluminum foil which is kept at the bed and after that what is it you could see so he opened the box right so what was there is you have an aluminum foil along with some what are these you can just yeah it's a small foam kind of thing right so that is present inside now the question is I'll give you a cloth okay hold it like this show it to them are you able to see anything from here are you able to see any connection between the roof and the bed nothing right now what you are going to do is you should not shake it much with whatever energy you have just try to rub on top of it till you're able to observe some phenomenon you guys tell me when should you stop you hold it in your hand okay and don't cover this part hold it like this or hold it like this okay hold it like this and apply some pressure don't shake it much apply some pressure Divya, are you able to see?
Yes, sir.
Yeah. No. Rub it fast. Pressure in the You can rub it fast. But see. Are you able to see something? What happened? Maybe if I rub it more, see that's because we lost some foam balls. Okay, when you opened it, no, because of air it fell down. If I rub it fast like this, so one thing is it fell down actually, but you could see something happening, right? What happened? See. They're sticking to the top, right? So maybe if I'm able to apply more pressure and do it, it will happen. So the question is, what exactly happened in this place? Now think of one logic. These balls, see, one ball just now flew up. You saw that? So these balls were doing their job, right? Everything was stable. We went disturbed it. It is going and sticking to the top pipe. If I ask you to explain the science behind it, can you try?
So positive and negative atoms.
So what actually did we do? by me rubbing it here, what did I actually do? I created, how did I do that? Through what process? So when you say charge, right, you need to answer this question of whether an electron is gained or lost. So what did I do? I created friction, due to which there would have been heat, and due to that heat, what would have happened? There would have been an excitation of electron, and the electron could have got lost, right, due to which the top surface got a charge. But these particles were actually neutral, right? But if you see, there is a gap here. They are not even in contact. Friction, I rubbed it literally, right? But there is a gap here. These particles were able to travel through this gap and come and sit at the top. Means, by me creating a charge here, what did I create around this? I told you in the beginning of the chapter. I created a field here. Due to this field, what happened is, that field went and induced charges in those neutral particles, and those neutral particles started getting attracted. So here, for me to understand the methods of charging, I can do it in two ways. What are they? One is through rubbing, that is friction, and the second is without a physical contact, which is called as induction. So these are the two important methods through which we can actually make this process work. Are you guys able to understand? So that's what the concept of method of charging is. Thank you. Yeah. So you can try this at home. The previous batch, those aluminum balls also came up. I don't know why it didn't come. Maybe the pressure was not sufficient. Right. So if I have to break it down into two parts, what are they? So methods of charging is one through the concept of friction, and the other is the concept of induction. Right. See, to some extent, are you able to visualize how these charges work? Right. Yeah. Okay. So, when I say through friction, if I have to put a simple block diagram, what will I say? Friction is basically when you rub one object against the other. Through friction, what are you able to create? Through friction, I am able to create heat. Due to the heat, what will happen? There will be excitation of electrons. There will be excitation of electrons. Then, due to the excitation of electrons, there is a charge created. So, I am not talking about whether it is positively charged or negatively charged. I am not getting into that concept at all. I am only talking about how the charge is created. Means, if I use the concept of this physical phenomena called as, this property called as friction, I will be able to create a charge on a material, and this is happening through the process of contact. Am I right? So this is happening through the process of contact. Now, when I say induction, right, what do you mean by induction here? Induction is something which happens without a physical contact. Are you able to understand? So if something happens without a physical contact, then you call it as induction. Meaning, if I have a material which is, for instance, positively charged like this, right? I have a material which is neutral. So when I say neutral, what is the meaning of it? It has equal amount of positive and negative charge. So inside this material, you have equal number of positive and negative charges. But because of this positive charge, an isolated positive charge, because it is independent, because of an isolated positive charge, through this medium, will it be able to interact with this in such a way that this isolated positive charge will try to pull the negative charge present in it closer to it. Make sense? So, the negative charge which is present here will come to the left extreme. As a result of which, the positive charge which is present in it will get repelled to the other side. So I told equal, that is why I drew 4, 4. Right. Now the question is this method called as charging or redistributing? It is just a redistribution. The material has not yet got charged. I have not created charge on this material. I will be able to say that charge is created only if there is excess of either of them. So it's my job to reduce them. Right? Since I took this scenario, I'll take this kind of a case where the charges have got redistributed. Now, as soon as I move this away, what will happen? They'll comfortably come back to their original positions. Right? So, in order to avoid that, what I'll do is I'll take this and connect it to the ground. So, this process is called as earthing. If I connect it to the ground, what will happen is this positive charge which has got generated here will go to the ground. As a result of which, what is it you're left out with? So then, even if you remove this, it is only going to have excess amount of negative charge. Then you say the material has got charged. But if you see in the whole process, what did we do? We didn't have any physical contact. That is why this method is called as induction. And this is so through physical contact is friction, and without physical contact is induction. As simple as that. Is that clear? Yes. Just make a note of it. Just make a note of it. See, this wall is still stuck. One is on the top. You would have done something like this, no? In your lower grades with a balloon. What will you do? Just rub it against some shirt, or you rub it against a dry hair, and take it close to pieces of paper. It will start attracting. So that gives you another important thing also. You remember I told you about the electrostatic force and nuclear force. What did I say? Nuclear force is many folds greater than the electrostatic force. Guys, observe, through this example, can I say that electrostatic force is stronger than the gravitational force? Because this object is being pulled against gravity. So it is actually 10 power 40 times greater than that. Electrostatic force is almost 10 power 40 times greater than the gravitational force. Understand? These are methods of charging. So we saw what is charge, what are the basic properties of charge, and the method of charging as well. Alright? So just conclude with maybe one more small activity. Tejas, can you come? You see, I'm using this pen to write now. I'm writing it here. Can I use my finger also to write? Can I? Sometimes. This works very well, Raghu. It works. Right. I can use 10 also. It says 10 point something. Okay. Now the question is, how is this function? Right. So what I'll do is, did you see? Yeah, I have my mobile here. Okay, come here. Just show it to them. What is the app I have opened? Some notes. You would have used this, right? So you are able to see a pen there. You're able to see a pen symbol there. Press on that. Here. So he has pressed on the pen symbol. Show it to them also. Okay, just scribble on top of it. So just keep it like this. I'll hold it. Can you scribble on top of it? He's able to do. He's touching and he's able to do. Okay, I'm not concerned about this. Okay, I'll give you this one. Why? Is it working? Why?
So this is an insulating material.
This is what?
Insulator.
It's an insulator. Right? What is actually happening here? The charge is getting passed from your body to this, and it is working. So you're able to understand. So simple electrostatics is actually working. And here, this uses the principle of capacitors. I told you, electrostatic potential and capacitance. So this is actually working on the principle of capacitive sensing. Have you ever gone to ATMs? Have you ever withdrawn money? Have you ever gone to some irritating ATMs which will torture you to keep hitting you? Like you need to keep hitting multiple times, it will not take the response. See, this one I'm not even doing anything. It's very simple for me. My life is very easy with this. I'm just scribbling. I'm able to see the things here. I just touch, it is working. But you would have seen certain ATMs and certain times when they're billing in some shops also, they take the credit card or card and keep hitting it like this. Have you ever heard that sound? You're not able to relate to what I'm saying. You have been to ATMs? I'm saying the old ATMs where you need to press multiple times. You have to press hard. Have you ever done that? Next time observe it. So those work on the principle of resistive sensing, means they use the concept of resistors. Whereas these devices which we are using, the smartphones which we are using recently, use the principle of capacitive sensing. The capacitors which you are actually learning in your syllabus. If time permits, I'll teach you how to make your own capacitor also, depending on that time. With a paper and an aluminum foil, you can actually do it. You can see the charge on it also. So that is how it works. So this is one sheet. There will be another sheet inside. So when they get pressed, there is a change in electric field. Okay, about that I'll tell after I explain electric field and all. But I wanted to show this to you for you to understand the concept of or understand the application of electrostatics. So what is your explanation for this? You told already. So charge from your body is actually passing. It is passing through this material, due to which it is able to sense. Right? Can I make this as a working stylus? When? If I take an aluminum foil and wrap around it, will it start writing? Provided I hold it on top of aluminum. If I hold it on the plastic, it will not still work. If you hold it on the aluminum and try to write, it will still work. Okay, maybe the response will be dependent on how you're wrapping it. Okay, sometimes if it doesn't work, what you can do is take a drop of water and wet it at the bottom and write it. Don't do it without a tempered glass. Don't write it on top of your screen directly. Doing this experiment will spoil your phone. Okay, so this is one of the applications of electrostatics. Like this, we have many such applications. Can you give me another application of electrostatics? Can you think of anything from your real time? As simple as dust on your table. It's electrostatics. The dust actually gets charged and it comes and sits on the top. You have a printing machine that also works on the concept of electrostatics. Are you able to understand? So that's how it works. So with this, I'll stop for today. In the next class, we'll get into the concept of electric field.